We are starting a new unit today, so topic 6. And first we're starting with exponent rules. So that's what this little book is supposed to help you with. It is something that you can use on a test, since you can use your notes on practically all tests, except for the retake, but even then, you know, I let you use that colored paper, so it's up to you whether you want to like fill that out and have it be useful to you. You can pretty much use your notes on all tests. So this flip book is considered notes. What you need to be able to do is recognize product rule, power rule, quotient rule, and negative exponent rule. So we'll talk about all of those today, at least a little bit, and then again Monday and Tuesday. And you need to be able to recognize when you need to use exponent rules and then how to correctly use them. So that is what you will be tested on. And the exit ticket for this lesson will be like a little longer than normal. So normally we just give you like 3 problems. Well, it'll probably be more like 10, because I didn't see too many exponent rule problems on the topic 6 test, like your end of unit test. But it doesn't really make sense to not teach this when this whole unit uses them. So it's kind of like what we call like a 0 unit lesson. So where it's something that you need to know before we can even move on to the rest of it. So just keep in mind, this one has a lot of rules. You need to be able to understand all of them. And that little flip book should be a lot of help. So I will, I'm recording right now and I'll upload it later, but these videos that are under here, especially the first one, we're actually going to play that one in class, will be very helpful to you. Because not only do they tell you the exponent rules and give you some examples, but they prove why they actually work. All right, and sometimes that's more helpful to memorize them. All right, so that video we'll watch here in just a second. The practice, so we're splitting it up into a day 1 and a day 2 practice, because this is probably going to take us like 3 days. So you'll just have a day 1 practice today, which is a Google form. You only get 1 attempt, so don't just like guess through it, because you only get 1 attempt. If I think you're guessing, then I will take off some points. But you should be trying to be accurate, because it tells you immediately after you submit it what you did right and what you did wrong. So take it seriously, pretend like it's a test, because a lot of the time kids think that they're doing it right, but they're actually not. And so that will be good feedback for you. And then a couple of reminders, since we just took our first topic test of the semester. I update grades within 7 days of submission. That's school policy. So if you turn something in, you do not need to email me, hey, Ms. Medina, I just turned this in. All right, I will automatically grade it within 7 days time. If for some reason I don't, then that's when you can email me and say, hey, just letting you know I turned this in like 10 days ago, can you check on it? Because either you made a mistake or you're confused. Either I made a mistake, like maybe I didn't see it, or maybe I didn't press save, I don't know. But then that's when you can email me. Otherwise, just know like it will automatically be graded. The second thing is that you guys took your retake yesterday. So, and it's a paper test. It'll probably take me a little while to grade it, but it should be in the grade book by Thursday. And that's going to be the better of the 2 scores between like the Galileo test and the paper test. So I need to have the paper test all graded before I can figure out which one you did better on. All right, so just be patient. That'll be in the grade book by Thursday. And of course, I'll always give you the points back on your exit tickets. Like if you scored an 80% on your topic test, I'll give you an 80% on your exit tickets that were below that. All right, so keep that in mind. Questions so far? All right, other 2 reminders. Tutoring I have it every Friday starting today till the rest of the semester. And it's from 2:15 to 3 p.m. unless something arises. Then you'll see a no tutoring sign on my door. But so far this year, I've been able to be here every Friday. So you just show up. You don't need to like sign up. You just show up to this classroom and I can help you. Otherwise, there is tutoring available in the library Tuesday, Wednesday, and Thursday from other teachers if you want to go and check that out. It's actually for English, math, and science. So that's a really great thing that we started providing this year. It's completely free. You just show up and they can help you. So really you can get extra help with math up to 4 times a week. If you go Tuesday, Wednesday, Thursday in the library, and then come to my tutoring Friday. So up to you, plenty of opportunities. This will not be on Monday, it should be Tuesday. But so far, this is like the schedule of tests that we have right now. So any questions? All right, I'm gonna play the video that I said was really helpful. So what I want you to do while the video is playing is on that quick reference page. So the first page, when you open your flip book, when they say a rule, like the product rule is this, you write it down. All right, and then listen to their explanation. Really try to understand their explanation. Of course, we'll discuss it in more depth after the video. But at least you know like that video exists and you can watch it anytime you're confused. So the adding and subtracting rule was not in the video, but it's something that you should know just from solving equations. All right, so don't overthink it. If I am adding and subtracting, say like, write it off to the side here. Say like 3x and 2x, what does that equal? 5x. So these x's, they do have exponents. What's the exponent if it's not written? 1. But notice when we're just like adding or subtracting, we don't change the variable or the exponent. All right, we don't like add the exponents together or something like that. All we're actually doing is combining like terms. All right, it's just that now you're going to see things with more than just like 3x and 2x. Maybe it's 3x plus 2xy plus 9xy. All right, you only combine means add, the terms together that are like terms. So like in this example right here, does 3x have a like term? No. So if you don't remember, like terms have the same exact variables to the same exact exponents. So 3x is basically alone, so just rewrite it. Does the 2xy have a like term? In this little example I drew right here. 2x. The 2xy, it's all one term. Yes, there's a 9xy. So you see how these have the same variables to the same exponents. They're both to the first power. So that means that I can combine these two terms. And when I say combine, I really just mean that I'm adding the coefficients together. So what's 2 plus 9? 11. So it ends up being 11xy. Because again, you don't change the variables or the exponents. You just combine the coefficients. Does that make sense? All right, so combine like terms. So keep variables and exponents the same. so that one wasn't in the video, but we've actually been using it all semester. So don't see like a bunch of other stuff and get confused. All right, the product rule. That one was in the video. What did it say? Good. All right, and this only applies to like variables with exponents or numbers with the same base. So like x would be the base number. They're the same. So that means when I say x to the m times x to the n, I'm really just adding the exponents together. So let's say I have, let's do 2x squared times 3x squared, or maybe let's pick a different one. 3x to the third. All right. You multiply the coefficients like normal. So let's do times 3. 6. But the variables follow the product rule. Since they're both x, I rewrite the x, but now I am, according to the rule, adding the exponents together. So what's 2 plus 3? 5. All right, that would be correct. All right. So questions on the product rule, and of course we'll do a ton more examples, but I'm just introducing. All right. So product rule says that we add the exponents. Quotient rule. What did you guys write for that rule?
X to the power of n over x to the power of n equals x or m minus n.
Good. All right, so write that down, and for some reason you didn't, even though I paused it, you should all have it down. All right, x to the n divided by x to the n is x to the m minus n. So we are subtracting the exponents in that case. And it's always the one on the top minus the one on the bottom. Right? Example of that, well, I think I'll just wait till we get there. All right, it's not really hard to follow. Power rule. What was the power rule? So that would be a power raised to another power with symbols that they give you. Good. So x to the n, and then in parentheses raised to the n. So an exponent raised to an exponent, like this with the parentheses. All right. In that situation, what are we doing with the exponents? We're multiplying. So notice how whatever the name of the rule is, we do something different with the exponents. Right? The product rule, we add the exponents. With the quotient rule, we subtract them. With the power rule, we multiply them. All right. That's why I'm taking time that we fill out this little book so that you don't get confused. Questions so far? All right, we'll do an example for power rule real quick. So let's say I have 2 to the x squared. So 2 times x squared raised to the third power. All right, coefficients you always treat the same. So it's really, and if you remember from the video, it said like this exponent would go to the 2 and to the x. It's really 2 cubed. So what is 2 cubed? Which equals 2 to the third power, which equals what? 8. All right, so the coefficients you treat like normal. 2 cubed is still 2 cubed, which is 8. But with the variables, you do something different with the exponents. It's not going to be 2 to the third power. The rule says that we need to multiply the exponents. So what's 2 times 3? 6. All right, so the name of the rule is what's happening between the base numbers, but between the exponents, you do something different. All right, negative exponent rule. What did that one say? Good. So write that down if you don't have that. And this one's really important because on your test, it'll usually say make sure that your answer does not have any negative exponents in it. If you don't use this rule, then you do lose points. So that one I'll kind of save for when we get to it in your little book. So just keep that in mind. Your answer should not have any negative exponents in it. All right, and the last one, the 0 exponent rule. Anything to the 0 power always equals 1. And I'm not saying x to the 1 or anything like that. Just the number 1. Questions? So now we're going to do a bunch of examples for each rule, starting with the product rule. So next page. All right, the product rule, you can fill it in from your quick reference page, or you can copy down what I'm putting. The video likes using m's and n's. I like using a's and b's. Doesn't really matter. Just understand the rules. So if I have x to the a times x to the b, that is equal to x to the a plus b. So we add the exponents together for the variables, for the same difference. All right. Now, a couple of these we'll do together, a couple of them you'll try, and then we'll see if you're right. So number 1, the x can be like the same variable, or it can be like the same base number. So in number 1, do they have the same base number? What is the base number? 3. So you can copy over the 3. And then because they have the same base, you can use this rule on the exponents. So what am I doing with the exponents? Adding them. So 3 to the 2 plus 6. Normally I don't write that every time, but understanding how we get the next one. So what's 2 plus 6? So my answer is 3 to the 8th power. All right, and normally when it's numbers, we'll actually put that in our calculator and say what number it is. But I'll let you box it up just so you can see like the rule being applied. Box up 3 to the 8th. But if I put 3 to the 8th in my calculator, it's 6,561. All right. Now let's look at with variables. So number 3, x cubed times x squared. Base number is x, so copy that over. What do I do with the exponents according to the rule? Add them. So 3 plus 2 is 5. Not 6. If you put 6, incorrect. You're adding them, not multiplying. All right, in number 6, there's some more stuff in number 6. But you always like match it up with the same So starting with the W, what are my exponents on each of the W's? So I'm gonna have W to the 2 plus 4. And then what about with the V? What are the exponents on the V? 1 and 6. Because what's the exponent if it's not written? So don't forget it. If it was 0, it wouldn't even be there at all, right? Because it would be replaced with the 1. So B to the 1, B to the 6, B to the 1 plus 6. You don't really have to write this every time, but just to help you. So my final answer is W to the what? W to the 6 and B to the. Good. Questions about just these first couple? All right, so I'm going to give you a couple to try. So try 5 and 4. And I'm going to copy a few down that I think you should all do. So it'll give you like 30 seconds. What did you put for number 4?
A to the 10th power.
Anyone get something different? All right, A to the 10th is correct. All right, so yeah, there's parentheses and stuff, but you know that sometimes they use parentheses to imply multiplication. All right, so if the base numbers, the A's are being multiplied together, the exponents, you add them together. So 9 plus 1. All right, what about number 5? I heard n to the 6th. Anyone get something different? All right, good. So remember, if it's not written, but it's there, like the n, what's the exponent? And then you would have to add them all together. So 2 plus 1 plus 3 gives me 6. So n to the 6th. Good? All right, and then I just want to remind you, coefficients, the numbers that are in front, like the 2 and the 3 and number 7. So look at number 7. You always treat those like normal. If the terms are being multiplied together, you multiply the coefficients together. So 2 times 3 is 6. It's only the variables that you use the product rule on. So k to the 9th times k to the 2nd gives me k to the 11th. All right, not k to the 18th. Don't multiply them. Add them according to the rule. Good? All right. So now we're actually, so like this whole unit that we're doing is about what are called polynomials and things like that. We'll talk about that later. But basically, we're going to be adding, subtracting, multiplying, dividing a bunch of stuff in a problem that looks something like this. So more things involved. Don't let it intimidate you. It's still all the same rules. So you see in this problem, we have like multiplication going on. We have some addition going on. Still follow your order of operations. So what comes first, multiplying or adding? So then you multiply these two terms first. All right, so we'll do that and then bring everything down. And then if we still need to keep going, then we keep going. Now you do it until you can't simplify anymore. So on number 11, we have to multiply these two terms. What's negative 8 times 5? Negative 40, good. And then it's the variables that you use your product rule on. So x to the 1 times x cubed, what do I get? X to the
4.
4, good. And then y cubed times y squared is y to the 5th. Questions? All right, and then bring down that other term that we didn't do anything with yet. So 3x to the 4th, y to the 5th. Now, the terms are being added together. But if you look at your rules, I can only combine them if they are like terms. All right, so like terms have the same exact variables, so the same exact exponent. So would you say that that's true here? Do they both have x to the fourth, y to the fifth? Then you can add or combine the coefficients together. What's negative 40 plus 3? Negative 37. And then just like we've been doing all year, when you combine like terms, you do not do anything with the variables or exponents. It's still x to the fourth, y to the fifth. You just combine the coefficients. So just like if it were negative 40x plus 3x, you could get negative 37x. But you don't change the variables or exponents when you're just adding and subtracting. Make sense? Good? All right. I want you guys to try number 12 on that little page there. Try that, and then we can move on. All right, so first you need to understand like how many terms you have, like how they're split up before you can really know what to do. All right, so how many terms total are in this problem? There are 4 terms. All right, terms are separated by like, it could be a multiplication sign like that. So there's 1 term, here's 2 terms, or like an addition or subtraction sign like that. So here you're seeing how many terms you really have. All right, I have 4 terms total. All right, that kind of helps you figure out, okay, what operations are going on. So I have some multiplication, subtraction, more multiplication. And in order of operations, 10 does what comes first, multiplication or subtraction? Multiplication. So going from left to right, look for any multiplication that you can do. It's normally multiplication, division in the same step, but there's just multiplication in this problem. So from left to right, I see that these are being multiplied, so I'll do that first. What's 9 times 3? Good. And then use your product rule on the variables. So you should have had m to the, which is good, n to the
1 plus 2,
which is
and to the third power.
good. All right, so all we did was multiply those first 2 terms together. I'm gonna rewrite everything. I'm gonna bring everything down. But I still have some more multiplication to do before subtracting. I have to multiply these 2 terms here in black. So multiply them out. What's negative 4 times 5?
Negative 20.
Negative 20, good. I get m to what power?
M to the 9th power.
M to the 9th. It looks a little sloppy on here, but probably looks better on your paper. M to the 9th. And then n to what power? N to the 3rd. So yeah, this middle term didn't have an n. So it's kind of like doing 1 times n to the 3rd. All right. Questions there? All right, then bring down what we had before that, the 27 n to the 9th n cubed. Now this is what we have. We have a subtraction problem. Sometimes they're not like terms and you just stop there. But are these like terms?
Yes, it is.
So then you combine the coefficients. What's 27 minus 20?
7.
Good. And then what do I do with the variables and exponents?
Keep them the same.
Keep them the same. 7 n to the 9th n cubed. Good there? All right, so don't lose your little flip book. Put it somewhere safe, maybe like in the pocket of your binder, somewhere that you won't lose it.